Testing, testing. Test, test, test.
Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Salam.
Okay, yeah? All right, good. Today, before we start, I need to just discuss briefly with one or two things. Number one is the section number. Number two is about our attendance. I'll show you the attendance afterwards. And I want to talk a little bit about that. And thirdly, which I was quite upset. I told you a few times already, use your own name, your real name in the WhatsApp group. And then also include your real name in your email so that, you know, I can record your attendance based on your name. Otherwise, it'll be a problem for me. So this is another, I think there are only one more person. You know, I checked last night, one more person. This is iPhone. I don't know who this guy is, iPhone. If you are iPhone, please, okay, put your real name. So if you don't do it today, I will remove you from the WhatsApp group. Because what is iPhone? You know, this is not your personal WhatsApp, okay? This is academic. So that's first. Number two, the section. When I get the iTalim group, everybody is being put into one section. Is that right? Do you still have your section 1, 2, 3, or everybody now in section 1 only?
Everyone in section 1.
Section 1.
Everybody is section 1, right?
Yes.
Because, you know, I thought we were in section 1, 2, 3, but when I got the list last week, everybody in section 1. So I want to make sure, you know, what I have in the list is consistent with your record. So now everybody in section 1, eh? Huh? So now, if everybody in section 1, then it does not matter, you know, whether your group member from section 1 and 3 previously, or, you know, 2 and 3, because your name is already being put together in one section. So there is no issue of section 1, 2, and 3, because the list has only one section. So according to your record, everybody, that is true, right? You everybody in section 1. Is that right? Is that right, or is it not?
Yes, sir.
Yes.
Okay, good. So section 1, everybody.
Yes.
All right. That's number 2. Now, number 3, I want to show you attendance, because like I said earlier, even though attendance, I don't, it's quite difficult to monitor, but I have record of attendance. I have, yeah. Can you see this? The screen, attendance? All right, now this attendance is for the 28th. 28 means last week, the latest class, 28, before the holiday, before the weekend. Now, if you can see the names, okay, this is good. I mean, your name are all here, real name. Except maybe this one guy, which I say, he use here, this iPhone, that's the problem with this guy, iPhone. And he came only for 4 minutes. So 4 minutes, you better don't come. Okay? If you are just to come 4 minutes, better don't come. Now. And another guy here is Daniel Hassan. Okay, Daniel Hassan, are you here? You come also for 4 minutes. If you want to cheat, you are cheating yourself. No, you don't cheat me. Okay, and there are a few people. I probably, if you come, your record here is 1 or 2 minutes, probably because of the internet. You after that you reconnect. So if that is the case, that's fine. And if you look at this guy here, Azizan, 1 minute. Okay, 1 minute. And this is Shamimi, 2 minutes. Haris, 4 minutes. Nick Amru, 12 minutes. But Shamimi did come again here, 2 minutes. But I don't see your name again later. Okay. Correct. And Sarah, 1 minute, 2 minutes. Here, no Shamimi again, 2 minutes. I don't know, is it the problem with your internet or what's the problem? Huh? Okay, this is Sarah, 45 minutes. I think Sarah is okay because you put in a few minutes. After that, you came 45 minutes. So that is the problem. It is Daniel. I think I already mentioned about that. And there are people who came. Yeah, Shamimi again, 7 minutes and 2 minutes. 2 minutes. Okay, Shamimi, do you have a big problem internet or what? Masuk sekejap. Okay, so that is not good enough, Okay, this is on the 26th. You see here, Ridwan, 2 minutes. And then Dana, 5 minutes. This one lagi tengok Humayun ni, Paris, 3 minutes. Ini 0 pun boleh masuk. And then this student here, D, Norliana, 1 minute. Okay, so okay, there are two possibilities. Okay, here I'm going to check into more detail, but there are 2 possibilities. Number 1, you have internet problem. Okay, you may have internet problem. You come in 2-3 minutes, after that you reconnect. That's fine. Okay, because I saw 1 or 2 people are like that. Now the other case is purposely come in and check out just to have your names in the attendance. I don't think that is working. Okay, if you just want to your name, if you just want to have your name in the attendance, it doesn't work that way. So if you want to come 5 minutes, better don't come. All right. If you want to come full time. Okay. So like you see here, Mina, you know, 84. And this is another iPhone. This iPhone, I think it just come 5 minutes, 10 minutes. This is 8 minutes, 5 minutes. I just wonder who is this iPhone? Okay, I'm talking about this guy for a few times already. Change your name. I'm very angry with him or her. I don't know who is this. You know, Mujahid, 99 minutes. So if you come, make sure, you know, come full time. All right. Don't just want to record your attendance. That is not good. If you cannot come, then you cannot come. All right. That's the reason. That's okay. Okay. But don't come for 2-3 minutes and then leave. Okay. That is considered also absent. So if you want to do that, please don't do it. All right. It doesn't work. So make sure our attendance sincere, you know, sincere. That means you are not cheating yourself. Okay. There is nobody else that you cheat except you. Okay. So please, all right. When I say self-monitoring, that means I really mean self-monitoring means you monitor yourself, all right, for the benefit of you, not benefit of me. Okay. So that is about attendance and then section number. Okay. Anything about last class before we begin? Okay. So what we do next is we're going to continue from where we left last class. We were discussing about the system of linear inequalities. So we will continue from there. That is where we stopped last time. We have the problem, all right, where you want to maximize or minimize the objective function subject to a set of constraints. We are already clear on the objective. Objective is a function, linear function, and the constraints are a system of equalities. So what you want to do here is you want to maximize the function, right? And the inequalities are the constraints. And of course, that problem is called the linear programming problem, or it's an optimization problem, because you maximize something subject to a constraint. So let's look at the problem more detailed. What you want to do here, okay, you want to solve that problem. All right. Now we are going to look at a method of solving this problem. The method that we're going to use is graphical method. So that's the reason why, you know, we draw graphs, because you want to do graphical method. And the steps that we have for this method, most of this we already learned, okay? Most of this you already learned. So of course, number one, you have the problem, right? The problem is the optimization problem that we have last page or last class. You maximize or minimize the objective subject to the constraints. Okay, that's the problem. Now, number two, what we do here is we will draw the inequalities. Okay, we draw the inequalities, which are the constraints. All right, the constraints on a graph. Okay, on the same graph, you draw these inequalities on the graph, and then we call this, you know, it's like a system. It's like a system of inequalities. And then we identify the feasible region or the solution. Okay, you identify the feasible region, call it FR. That's the criteria. All right. So from the constraints, we have a system of inequalities. We draw it on the same graph, identify the the feasible region, and locate the feasible region. All right. So this one we already know. And then number 3, we determine or identify, determine the corner points. Okay, the corner points in the feasible region. So from the feasible region, you need to identify the corner points because the solution will be one of the corner points. The solution will become from one of the corner points. Now, what is a corner point? Corner point, we are talking about corner point in the feasible region, all right? So corner points means border point. So it must be at the border, at the end, okay, border. And it is defined as intersection, just like intersect, you know, the solution. Intersection of 2 or more equations. Now, what do we mean by this equation? This equation will come from the inequalities. All right, the equation that correspond to the inequalities of our system. Okay, one intersection of 2 or more equations, which correspond to the inequalities in our system. All right. So this inequalities is the inequalities in the system, and that is coming from the constraints. So this is corner point. So we need to identify the corner point. All right. Corner point is intersection of 2 or more lines, which made up the constraint. So we don't care about the lines outside the feasible region. Okay. We only care about the corner points within the feasible region. Okay, so the corner point is, of course, at the border. So if we can come back to our example last time, where was our record? Okay, this one. Okay, we come back to this example. Assuming, okay, assuming x less or equal to 65 is a constraint. Yeah. So after we do the inequalities, we draw the inequalities, we identify the feasible region, which is the triangle there. Okay, triangle tu kita dah ada lah. So now, what is a corner point? A corner point is a borderline. Okay, a border point. I'm sorry, not a borderline. Border point. That is an intersection between 2 or more lines in the of the equations that correspond to the inequalities that you have in the constraints. So an example of a corner point is this. If you look at the feasible region, this is one point. Okay, call it point A, where intersection of 3x plus 7y equal to 170 and 5x minus 2y equal to 104. So that is one point. Another point is this. Intersection between 3x plus 7y equal to 170 and x equal to 65. The other one is up there. You know, it doesn't show the corner point because of my page. but it's there. If you draw your graph big enough, you will see there is another point. So to call that corner point B, there's another point C, somewhere there. Intersection of x equal to 65 and 5x minus 2y equal to 104. So here, all right, you have 3 corner points. So we need to worry only about the corner points. The solution would come from these points. One of these points would be the solution. So we want to move on to what we do next, okay? So after you identify the corner points, you determine the points, all right? That means you have to find the coordinates. So you exactly know where they are, okay? For example, that point A, you have to find what is the value of x and what is the value of y. So you have to find the value of xy for each of the corner point, all right? So after you have done that, you list down the corner points. After we have determined the corner points, you list down all the corner points. Say, for our example, you have A, B, C. Now that corner point, of course, depending on, on the problem, you can have 1, you can have 2, you can have 4, you can have 5, it doesn't matter. So say you have 3 based on the example. So it's good that we tabulate the corner points. So here are the corner points, call it CP. So you got the point A, point B, point C, all right? And then what we do next is that you find the value of the objective function. You put into the points, all right, the objective function, and then you find the value of the objective function, okay? So that is basically the method. And then what method is that? That's 3. So this is number 4. Okay, and then number 5. We're going to discuss this in more detail afterwards. All right, this one I will go in more detail. This is just outline. And number 5, we identify. Because we do it by graph, you identify the solution. Okay, from which is given number 4. You identify the solution from table in 4. All right, so that is basically the method. If the problem is maximizing, then you find the maximum point. Okay, what value would give you the maximum value? I mean, not the maximum point. The point, either A, B, or C, that give us the maximum. Give us the maximum value. Okay, maximum value to the objective. If it is a minimization problem, then we will identify the point that give us the minimum value to the objective. So number 4 and number 5, we are going to discuss, right? Any question? Okay, that's the method, okay? That is the graphical method. So if you look at this method, we already know 2 and 3, all right? 2 and 3 we already know. And then number 1, of course, we have to come up with a problem. You know the problem, okay, maximizing or minimizing. And then we will find or determine the corner points. And the corner points, of course, are the intersection of the what do you call it, of the equations that correspond to the inequalities. Okay, any question? All right. So what I will do, we will continue from where we left, using the example that I have earlier. Okay, so that we don't have to draw any other graph. So we go back to this example. Okay, we already have the feasible region, all right? We already have the system. Where are the inequalities? Okay, where mana inequality? Where did I write down inequalities? This point. So tak apa. We will write down the problem. Okay, here. I have the, oh, there's another system. So, oh yeah, here is the system. All right. So you have the system here, which correspond to that diagram. So I will modify this problem. So we have the problem. Another constraint would be is a plateau. Another constraint will be x less or equal to 65. So that would be our constraints or the system of inequalities. Which you have the graph, okay? So let me just put the complete problem. Now the linear programming problem or the optimization problem, you have, okay, I will write down again here, you have maximize or minimize an objective function subject to a set of constraints, all right? So let me put down the problem. So suppose you want to maximize an objective function, say 4x plus 4x plus 7y equal to k. Okay, subject to that set of constraints. 2x minus 2y bigger or equal to 104, 7x plus 7y, 3x plus 7y bigger or equal to 170. This is x. That's y. And then x less or equal to 65. So that is our problem. Okay. Maximize the objective function, which is linear. Okay. Now, if you look at the objective, you will see the following. You see 4x plus 7y equal to k. Now, that k is constant. Okay. Now, it's a constant, but that constant will change. Okay. That constant will change. But that constant will change according to the x and y. Because you have the corner points. All right. The corner points will be a few. And then what you do, you substitute the corner points into the objective. We will get a different value of k. All right. So k is a constant, but K will change with different X and Y, okay? And that different X and Y will be the corner points. So what we are looking at is actually, when we say the maximum or the minimum, we're going to look at this value, okay? Value of the K, maximum or minimum. All right, I'll give you an example. Let's say one of the corner point is 5, 11. Okay, and then another corner point, say 10, 24. All right, so you have these two corner points. Now, how do you know which one will maximize or minimize the objective? We substitute. Okay, we substitute, and then you will see that the value of K. What is it equal to? So if we substitute the first one, then what you have is 4 multiplied by 5 plus 7 times 11. What is it equal to? 20 plus 77. Apa?
97.
97.
97. So that's the value of K. Okay, you put in 10, you got 4 times 10 plus 7 times 24. All right, so you got 40 plus 24 times 7, berapa? Anybody calculator?
208.
100?
208.
200?
And 8.
8. 208. 208 eh? Betul?
Yes.
Yes.
All right, good. So you see here the value of the K, okay, it will change. That's a constant, but it will change according to different value of Y. So this is the value that you're going to look at. All right. So if the problem is maximized, you want to look at the maximum value of the function, given, the corner point, given that corner point. So if you want to maximize, that means the maximum value is 208. That corresponds to 10 and 24. If you want to look at the minimum, that will be 97. Of course, that will correspond to that point, 511. Okay, so that is how we are going to make use of the objective, all right, and the points, which are the corner points, to determine the solution. Okay, all right. Any question? Because this one is the one that we are starting new. Okay, with this one, we have not discussed anything yet about this. So this one will be the new step, all right, for which you want to develop the problem. Okay, any question? No, okay, good. So what I want you to do, given the problem, okay, I already give you the objective, and that is already the feasible region, okay? I want you to find these corner points, A, B, C, okay? Do it quickly. All right. What I want you to do is this, so that we will not be overlapping. So I want a few people to do the point A. So you find point A if your name start with A. Because I don't know, because I don't see you, so I don't know you. So if your name start with A, find the point A. Now point B, this one, if your name start with M, find B. And point C, if your name start with with N, okay, find point C. Other people, your name starting with other letters, you do whatever you like, all right? But I want this group. If your name starting with A, you find the point A. The name starting with M, find point B. If your name start with N, find point C. So that we can do it very quickly, okay? Others, you just choose whatever you want to find, either A, B, or C. Okay, do it now. Okay, 1 minute. I think the more difficult one will be point A lah. Okay. Correct. The first person who get any point, let me know. All right, so that I can list this down. Okay, we have the problem, right? And then we draw the graph. We identify the feasible region, and now you find the corner points. So now corner points, we have to determine. Okay, I say determine. That means point A, you have to solve the system. All right, solve the system of equations, which is the two equations. And then you also need to find B. Also, you have to solve the system. And then you have to find point C. You also have to solve the system. Okay. So now let's say we already do that. We tabulate the points. So I just write down here. Here is the corner points. That is the objective. Okay. And then you have to find the value. Value of the K. Okay. Now, anybody got point A already? Point B? Point C. Anybody got point B, C, or, not necessarily in order? Cepatlah, we don't want to waste time. Anybody got A, B, or C? Cepat. Yeah. Hello, hello. Are you there?
Yes, sir.
Okay, siapa dapat point A? What did you get? You find point apa? Point A ke B ke C?
A.
sir.
Okay, A, give me A. What is the point?
X 26.05.
26.05.
Y 13.125.
13.125. So I think we make it like 2 decimal point cukup lah. So 13.13 lah. Okay. Okay. Is anybody who do point A? Do you get this similar same point? If you have a different point, probably somebody is not right. So let's go back to the graph. You have 26 and 13. That makes sense. Okay, because 26, 13. Oh, maybe my graph is not very accurate because according to this graph, it's about 30. Okay, so actually it'll be 26 somewhere here. All right, so that's why you need to find the points by using the mathematical form, because sometimes our graph may not be very accurate. Now, is this correct? 26.5, or anybody else get another value?
No, sir.
No, sir.
Betul eh?
Yes.
Okay, good. Now point B. Anybody got point B? Actually, point A is the most difficult to get, you know. So point B and C, it's quite simple. Anybody got point C and B? Hurry up. People with M, you know, your name starting with M, I want you to do B. Anybody got B? The value of X is already being determined, okay? It's what, 65. You need to find only the value of Y. So that one you can do in 30 seconds. Okay, what is B? 65 and what? And C is also 65. You need only to find the value of Y. Cepatlah. Yang point B tu.
Point B, 65, -4.
-4. Okay, -64. Okay, yang atas ni, C. 65, -4. Okay, that's B. Okay, C.
110.5.
110.5. Okay, good. Thank you. So you have the points. Okay. So based on the problem, we have the corner points. Of course, the corner points come from the constraint. That means we need to spend some time, you know, to find or to determine the corner points. Don't base just on the graph. Okay, graph is, even though you draw the graph according to scale, but still, you know, it's not accurate. All right. So the only way to determine accurately is by solving the system. So you have the corner points already. And then we have the objective. What was the objective? Saya dah lupa dah. Objective ni apa? Objective was 4x plus 7y. So objective 4x plus 7y equal to k. So substitute, all right? Substitute into the objective, the corner points, and then you'll see which one give you, or which one will solve your problem. Here you want to find the maximum, okay? So you have 426.05 plus 7 times 13.13 equal to whatever the value is. Okay, you find, okay, I will write down the substitution, you find the value. And then the second point B, you got 4 times 65 plus 7 times -4. And then you have another one, 4 times 65 plus 7, 110.5. Okay, what is the value for the 4.8? What do you get? Anybody already did?
196.11.
196.11. Okay, point B?
232.
232. Okay, C?
1033.5.
50?
1033.
Oh, 10. I'm sorry. Thank you. Sorry. 10. 1033.
And
Yes.
5.
Okay.
Yes.
10. 1033.5.
0.5.
Okay. So these are the values of the objective at the corner points. Okay. Now you go back to the problem. The problem was maximize. All right. Maximize the objective subject to the constraints. So you look at the table here, you will find, or you will determine, or you will locate the maximum value of the function. So the maximum value of the function is 1033. So you just put a star, or you just put a tick, or you know, just put some symbol. The value or the maximum value of the function is 1033, and that corresponds to point what? Point C. So this is our description or our conclusion. We say the maximum value of the function of the objective, okay, is what? Is 1033.5. And the point, okay, the point that maximize the objective is the point C, okay, maximize it is the point C, which is 65, 110.5. Or you can say the point that maximizes it is x equal to 65, y equal to 1110.5. That means point C. Now, if, okay, if the problem is to minimize, everything will be the same. Okay, everything will be the same up to the table, up to here. Okay, everything the same, except if the problem is minimizing, then what we do? We look at for the minimum value. Okay, you look at the minimum value. And if you look at the table here, if the problem is minimization, then we identify the minimum value. So what is the minimum value? The minimum value is this one, 197.11. I put in different color. And the point that minimize that function is point A, x equal to 26.05, y equal to 13.13. So I put here in the bracket, if the problem is minimizing or minimization, then you have the minimum value of the objective is what? Is 197.11. And the point that minimize it is point A. Okay, 26.05, 13.13. So that is our solution. Either it is minimization, it is maximization. The method is the same up to the table, okay, where you identify the value to the function that will correspond to any of the corner points. Okay, all right, good. Any question? Okay, I have discussed quite detailed, the method. So this thing here, because it takes time, if I want you to do it in the class, one problem that will take quite some time. So therefore, I would like to give you a few questions, for your practice. And I think we already did this example quite extensively, quite in detail. So I'll give you a few questions, that will solve the optimization problem. So go to example number, no, not example. Go to exercise 14.2. So I'm sorry, not 14.2, 4.2. Okay, 4.2, I would like you to do some questions. Okay, do number 10. And then do number 11. Number 22. And 23. All right. Now, number 10 and 11, they give you the constraints, positive constraints, x bigger or equal to 0, y bigger or equal to 0. If you look at 22 and 23, they don't, all right? They don't give you this one. That constraint x bigger or equal to 0 is not given. So I give you 4, all right? You can do, if you're comfortable, you do only 2, either one of this and one of that. Okay, at least you do 2, okay? At least 2. If you do more, that's fine, but at least try 2 of this. So find the corner points, okay? Determine the corner points by solving the system. This problem actually is not difficult, but it may take a little time because of the steps, So I would say just need time. So the more you practice, the faster you can go. So that's I think will be enough question. 4 questions. That is on the system. Now, what I would like to look at is going to look at application. Okay, the application of the linear programming problem. So that is what we're going to do next. We'll be looking at the application. So application is 4.2, I think. So let's look at the application. Okay, we look at the example of 4.2. Okay, application 4.2. I want you to read example number 2. Okay, example number 2. This is the application preview. Okay, I want you to read that example. Example, I think, you know what? We start with example number 4. We start with example number 4, not example 2. Okay, start example 4. All right, I want you to read that example 4. Now, example 4 is minimization. Okay, minimizing the costs. So if you use another edition, probably example 4 is different. So whatever the example is, my book, example 4, that one is the minimization of costs. Okay, read that for a few minutes so that we have some idea of the problem. Okay, when we have application, okay, our main task is to come up with the optimization problem. So we want to set up the problem. That means you want to see, or you want to know specifically what do you want to maximize or what you want to minimize and what are the constraints, okay? So when you set up the problem, you want to come up with the objective function, And then you want to come up with the constraints. So that is our main job. All right. So objective, constraints. Okay, this is a guideline. Number one. You develop the problem. I mean, you develop a problem. What is the problem? What is the problem about? Maximize or minimize. Okay. Minimize what? Okay. Maximize what? Minimize what? So what is the problem and what is constraint? So when you know what is the problem, you want actually we know what is the objective. All right. What is the objective? And then when you know the objective, you can find or you know what are the variables. That means you can find X, Y, the variables. All right. What are the variables? So what is X? What is Y? You know, according to that particular problem. Okay. And now number 3, find the objective. That means you find X and Y. And then what are the X and Y? And then you will need to find also, you know, you got the AX plus BY equal to that K. So you need to find what is A and what is B, so that you will have the objective. So you need to find A, you need to find B. The K you don't find, okay? The K is the one that you maximize. You need to find A, B, which are the coefficients of X and the coefficient of Y. Okay, and we know the objective will be that form. All right. Okay. Number 3, you come up with the constraints. What are the constraints? All right. So here you want to find the constraints. So number 4, you will develop the constraints or find the constraints which, okay, in effect, that will give us the inequalities. Inequalities. Okay, so you have the constraints, and the constraints are the limitation. Okay, they will give you what are the constraints. And then number 5, we relate. Okay, relate the variables to the constraints. So normally we can tabulate it. All right, you relate the variables to the constraint. That will come up with the inequalities. So once you have that relationship between the variables and the constraints, we already come up with the inequalities. So you have the objective, you have the inequalities, and then we already have the full problem. Okay, full problem meaning you have the objective, and I have the constraints or the inequalities. So this is the guideline of the way to do. So we will have clearer idea, you know, when we look at that example. So go back to example number 4. Now, in example number 4, you have an idea, okay, what is the problem about? All right. And then from there, you will get the objective. And then we will come up with the inequalities or the constraints. So firstly, what is the problem about? You have to know, the background of the problem. What is the problem about here? You have what? You have 2 plants. So it's good that you summarize the information. You have 2 plants. What are they? One in Macon, all right? The other is in Jonesboro. Okay, 2 plants. And these 2 plants producing what? Producing 3 types of product. Okay. What do they produce?
LP.
They produce fertilizer.
LP.
3 types: low phosphorus (LP), medium phosphorus (MP), and then HP. Similarly, the other plant, they produce the 3 products. Okay, the 3 types of fertilizer. So here, you already have the information or the problem. There are 2 plants, Jonesboro, Macon, producing 3 different fertilizers, or call it 3 products. Okay, so that is first information that we know. Okay, now if you look at if you read the problem, they say at each plant the fertilizer is produced in a single production run. So 3 types are produced in fixed proportion. So the plant in Macon produces 1 ton, 2 ton, 3 tons in single operation. So in a single run, I mean single operation, that is how much the different plant can produce. All right. And then you'll see here, they give you also the cost. Okay, the cost to produce the one run, and it charges. Okay, what is the cost? And then if you look at the other plant, they also tell you that. Now, question is, if the customer needs 100 tons of LP, 260 tons of MP, 180 tons of HP, how many production runs should be ordered from each plant to minimize costs? So from the question there, you will know the objective. Okay, what is the purpose here? What is the objective? The purpose, what is the purpose of the problem?
Minimize.
Minimize. So the problem is to minimize costs. Okay, minimize costs in terms of what? For each plant, in terms of the production run. Okay, so minimize costs at each plant in terms of what do you call it? Operation run. Okay, the cost of operation run. So the cost operation run at each plant. So from here, all right, from here we can get what are the variables. Okay, what are the variables? The question say, I want to minimize costs at each plant, or if you look at the specific sentence, how many production runs from each plant to minimize costs? How many operation runs should we have, to minimize costs at each plant? So from there, you will see the variables. So the variables in general would be the plant. Okay, because we're talking about the cost at each plant, but it is not the plant. What is it about? It's the operation run. So the variables are the operation run. Okay, the operation run, the production run at each plant. All right. So we can be more specific. You can let X be the number of operation run, or the operation run, or the production run at Meccan. In numbers, okay, or in units. And then Y is the operation run at the other plants, which is the Jonesboro, also in number. So from here, you already have the X and Y, okay? And of course, that is the objective. The objective is to minimize the cost of operation run at each plant. Okay, all right. Now the objective, the general form is what? AX plus BY equal to K. Now you don't need to find the value of K. What you need to find is the value of A and B. Okay, so we know X is the number of operation run in Meccan, Y is the number of operation run in Jonesboro. So if you look at the question again, one operation run, what is the cost per operation run in the different plants? So you will see here, it charges 600 to produce one operation run in Meccan. So here is the number of operation run in Meccan. So the point, or the value A, okay, is what? Is the cost per unit, cost per operation run in Meccan. So this is the cost per run in Meccan. And of course, the B would be the cost per run in the Jonesboro. All right, and Y is Jonesboro. So the objective is what? Objective is 600X plus, what is the cost per unit in the Jonesboro? 1,000. Okay, equal K. Or here they put C, doesn't matter. All right. So the A and B, all right, A and B is actually some average value. Okay, you will be given in the question some average value, cost per unit, profit per unit, or production cost per unit. All right. So you will get that from an average value. So you know the cost. You can find the total cost or the total profit by looking at what? Looking at the per unit value. So here is the cost per operation run in Meccan, cost per operation run in Jonesboro. Therefore, you get the objective. So these are how you get the coefficient of the X and the coefficient of the Y. Okay, all right. So now let's build up the inequalities or the constraints. So in order to do that, we will relate, okay? You will relate the idea of the variables, which are, you know, the operation run in the Meccan plant and the operation run in the Jonesboro plant, relate to what? Relate to what is the limitation? Okay, what is the limitation in terms of producing the product? Okay, so if you look back the question, you can see here the customer needs 100 ton of LP, 260 of MP, 180 of HP. So basically, that is the constraint. Okay, we are producing each of the three products at the different plant given those orders. Okay, so those orders are the constraints. So we're going to relate, okay, tabulate. So here, make a table. Tabulate the relationship, right? So you have what? You have two plants in terms of the operation, Jonesboro. This is the operation run, the number of operation run, okay, X and Y. And then you have the products, LP, MP, HP. And then you have the order, okay? The order constraints, the order of each of the products. So basically, the constraints are the quantity of the three products. So you have the variables here related to the constraints, all right, in terms of the quantity of the LP, MP, HP. So what is the constraint on the LP? Because the order the customer need is 100 tons. So that is the constraint. What is the constraint of MP? 260. What is the constraint on the HP? 180. All right. Now you look at the per unit requirement. So you go back to the question. You can see that the Meccan plant produces what? In one operation run, the Meccan plant produces 1 ton of LP. And then 2 tons of MP and 3 tons of HP. And then for the Jonesboro plant, per operation run, that plant can produce 1 LP, 5 MP, 1 HP. So from there, you have the relationship that relate the variables to the constraints. Okay? So from here, you can come up with the inequalities. So now, question is it bigger or equal to, or is it less or equal to? The customer order 100 tons. Of course, you can put it equal to, but you don't want equal to. We want inequalities. Okay? So if it is an order from a customer to you, they say 100. So if you are putting it in inequalities, are you producing less or equal to 100 or more or equal to 100?
More.
More. Okay? Because it's the order from the customer, you can produce more. At least you produce that much. All right? So it should be at least 100. It can be more. So the relationship should be bigger or equal to. All right? So similarly for this one, similarly for that one. So now you have the inequalities. So our first inequalities, so I just write down the inequalities. First one will be x plus x. I'm sorry, not x, y. But y, the other variable. So x plus y bigger or equal to 100. The second one, 2x plus 5y bigger or equal to 260. And then the last one would be 3x plus y bigger or equal to 180. Now this is the LP constraint. This is the MP constraint, and that is the HP constraint. So if you go back to the table, we will have the inequalities for the constraints, all right? 1x plus 1y bigger or equal to 100. 2x plus 5y bigger or equal to 260. That's for the MP. For the HP, 3x plus y bigger or equal to 180. So you have the inequalities. So you have the constraints. All right. So that would be our constraints. And you have the objective. So now we have the formal problem. So our problem now becomes what? Minimize the objective, which is 600x plus 1000y equal to k, or you use the book, you use equal to c, subject to the constraints, which are what? Which are over here. So you write down the constraints there. Subject to, rewrite. Okay, I want you to rewrite it so that we have the proper problem. So once you have the proper problem, you know the objective, you know the constraints, which are the inequalities, then you will be able to solve the problem. Okay, so to solve the problem, we are using the method we just described. Firstly, just looking at the inequalities, and then come up with the feasible region, get the corner points, and then one of the solution will be the corner point. We do it by substitution. So the constraints are the inequalities, all right? And then you have the full problem. So the problem is minimizing, not maximizing. So what you will do is you want to find the minimum point, okay? Now the problem here, if you look at this example, everything is given, all right? You are given, they do it already, the graph, they give you the solution. Now, I want you to do it on your own. So this problem here, I want you to finish it up. So the answer in the book give you only your guideline. So I want you to draw the graph, identify the feasible region, all right? And then this tabulate the corner points, and then get the value of the objective, and then describe the solution as per what we have discussed earlier. Okay, I want to note also here, for application, the x bigger equal to 0, y bigger equal to 0, this is automatic. Okay, this is built in. So if you don't specify, it's okay, because we know, okay, we know when application, we only look at the positive part of the x, the positive part of the y. So you don't worry about the negative side, all right? So make sure you are aware of that. So application, we only do this thing. Well, sometimes you don't have to specify, but it is understood, right? We just look at positive x, positive y. Don't worry about the negative values of x and y. Okay. All right. Any question? Any comment? Anything? Okay. Now you can turn on your mic. You know, you can turn on your mic when you have a question or you have comment. Okay. But other than that, you may turn it off. Okay. So that's fine. That's why I don't mute everybody, because I want so that it'll be easy for you to say something, either make a comment or asking question. Okay, anything? All right. Okay, I want you to finish this up, and then yeah, I should give you some more question. So I'll give you this question, okay, for the applications. Again, 4.2. First is number 25. Now here, if if you have other addition, maybe the question number is different. This one is on the manufacturing. Okay, number 25. And then number manufacturing. Okay, number 28 is also on the manufacturing. So I think 2 is enough. 1 is maximize profit. Yeah, both are maximizing profit. I want to find something that minimize cost. Mana minimize cost? Tak ada. Okay. So minimizing cost, number 39. All right. So put 39, it's also manufacturing. Because we are business, economics, accounting. So we just do the manufacturing. 25, 26, 39. Okay, so you have maximizing, minimizing. Minimize, maximize profit, minimize cost. Okay, so I think that will do it for today. Now that will be the end of chapter number 4. So we are done with this chapter 4. So chapter 4, we only do 4.1 and 4.2. Don't worry about the other parts. So we're done. And then Wednesday, I will give you a question. Oh, no, not question. I will give you, or we will start with another topic, differentiation. Okay, one of these questions, all right, 25, 28, 39, or I may give you, I think I will ask you to do one of these questions. Okay, this one one of them will become our assignment number 1. Okay, this one I will inform you on Wednesday. So just do it now, okay? And Wednesday over the weekend, I want you to do it nicely to be submitted as our first assignment. Okay, all right, good. Anything before we go? Any question or any comment?
No,
Okay.
sir.
All right, good. I'll see you again. Have a nice, not weekend, have a nice doing homework time. Okay, I give you quite a number of questions. Practice this. If you have a problem, okay, discuss with your friend, or you can what do you call it? You can put a message in the WhatsApp so that we can help you. Okay. So I will see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Thank you.
Sir, thank you, sir.
Waalaikumsalam.
Thank you, sir.
Thank you, sir.
Nice day, sir.
Thank you, sir.
Thank you, sir.
Thank you.
What question though?
Okay.
Happy Monday, sir.
Practice Orlando. And anything, any problem, put in the WhatsApp.
Okay, sir.
But our WhatsApp group is still section 1, 2, 3, so that'll be more manageable. If you have one group, with 150 people, it's quite a problem. So as of now, you don't move away from your group. Okay, we maintain the section 1, 2, 3. Okay, all right, good. So I'll see you again.
All right, sir.
Okay.
Thank you, sir.
Thank you.